Hello, Algebra 1 students. We're going to continue rolling with this same quadratic function and learn even more about it. F of x equals y equals x squared plus 16x minus 15. I've kept my extremely crude drawing on the board here. You should have desmos.com in front of you to look at a very nice graph of this quadratic function. First thing I want to say is this clearly doesn't seem to be the point 0, negative 15. That's one reason why this thing is crude. It really should be way further down here. The most obvious thing to notice about a quadratic function from its equation is the y-intercept, because when you plug in a 0 for x, these two terms go away and you're left with y equals negative 15. The point 0, negative 15, which should be down here more, is the y-intercept. That's easy. In the previous video, we found the two so-called zeros, the two values of x that make the function equal to 0, and they were negative 8 plus the square root of 79 and negative 8 minus the square root of 79. These are the approximations of them here. And we're going to now take a look at the vertex. As I believe I've taught you before, because of the symmetry of a parabola, the symmetry of the quadratic graph, the vertex holds a special place. If we imagine a vertical line that goes through the vertex, the two sides of the parabola, we could imagine folding them over that vertical line, and they would fall point for point right on top of each other. That's why that vertical line through the vertex is called a line of symmetry. And where is this vertex? Well, because of the symmetry, it has to be halfway between the two zeros. If we take the two zeros, even though there's that ugly square root of 79 in it, watch what happens. If we want the number that's halfway between negative 8 plus the square root of 79 and negative 8 minus the square root of 79, finding the number that's halfway between them is their average. So we will do negative 8 plus the square root of 79 plus negative 8 minus the square root of 79 and divide by 2. The average of the two zeros will give you the x coordinate of the vertex, because that vertex has to be left to right halfway between the two zeros. Watch what happens here. That ugly square root of 79 goes away because you've got plus and minus, they add to 0. Then you have negative 8 plus negative 8 over 2. That's negative 16 over 2, or negative 8. So that's the x-coordinate of the vertex. And going back to this notion of line of symmetry, that vertical line, and you could do this on Desmos, along with this graph, on a new line where you type in the equation, put in x equals negative 8. X equals negative 8 will give you a vertical line that goes through the vertex. That's known as the line of symmetry, as I described earlier, because of that idea of being able to fold the graph over that line of symmetry. So the line of symmetry is always x equals the x coordinate of the vertex. X equals the x coordinate of the vertex is always the line of symmetry, and it's a vertical line. As you know, x equals a number is always a vertical line of symmetry of the quadratic graph. So we've taken care of line of symmetry. Back to the coordinates of the vertex. Well, we have the x coordinate. How do we find the y coordinate? Well, it's going to be f of negative 8. That's always what you have over on the right side of the t-table going along with the x on the left side. You have x and you have f of x. Evaluate the function for x equals negative 8. And we'll go through that. Very simple rational number. Maybe it's even integer operations, which should be very simple. So f of negative 8, plug a negative 8 in for each x, but be careful when you're squaring a number, when you're squaring that negative 8, it's going to be positive. Put it in parentheses. Negative 8 squared plus 16 times negative 8 minus 15. When you square that negative 8, you get positive 64. 64. And then 16 times negative 8 will be negative. What is it? Negative 128? Negative 128, and then minus 15. Let's put these two together. 64 minus 143. Is that right? And then 64 minus 143 is the opposite of 143 minus 64. So it's going to be negative 79. And I remember that from Desmos. Negative 79. That's what the f of negative 8 is. So that is, oh, and I had it over here before, right there. The coordinates of the vertex are negative 8, comma, negative 79. You'll have to scroll down quite a bit to get to that vertex, but you'll see that that's where it is. And let's say one other thing about that vertex. For this particular function, that vertex is known as a minimum point, and this is one of the many situations in math. It's not all the time, but most of the time, the words we use in math make sense. This parabola opens up. You know that because the a is positive. The a is 1, positive 1. When a is positive, the parabola opens up. Whenever the parabola opens up, the vertex is known as a minimum point. And make sure you understand what that means. We could stay here until the end of time putting in values of x. We will never get a number for y lower than negative 79. That's the lowest point or the minimum point of the graph. Now, how would we know algebraically? How could we look at this and know that it would never be less than negative 79? Well, you can't really until you learn about quadratic functions and their graphs. It's where the vertex is that tells you that algebraic fact. This value here of x squared plus 16x minus 15 can never be lower than negative 79. That's why it's called the minimum point. If a is negative and the parabola opens down, then it's a similar thing, except for the parabola is opening down, that vertex is a maximum point. The function can achieve no value higher than the y coordinate of that vertex. It's all very straightforward. It makes sense. As with any math, make that sense for yourself. Tell yourself the story until you achieve that wonderful level of understanding. Well, that's it for now, ladies and gentlemen. I think I've covered these bullet points that I wanted to talk about. There may be one more. We might do one more video regarding this function. We want to look at something that is a part of all of this study of quadratic functions. We want to look at this thing, negative b over 2a. It's in all the Algebra 1 textbooks. I want to try to make negative b over 2a make some sense to you, and we'll cover that in the next one. Take care and enjoy quadratic functions.